Hello, this is the Blue Angels project proposal for the Blue Angels Power Tower. We are in FSC 100. Our class is from Tuesdays from 9 to 12. I'm Michael Sakata, part of Group 3.
Mario and Lewis.
And I am Sukhpreet.
And yeah, we make up the Blue Angels. So our problem statement is that we need to design a power plant for Sparkyville. Now this power plant must rely on renewable energy. So the three options are wind, air, and solar. And we must have consistent power. Short bursts of power are really not desired.
So we need to create a really versatile platform which must be compatible with high and low power inputs and give optimal power output.
Top design goals, we want to make optimal turbine blades. So we want to make our tower spin efficiently. And we want to at least generate 50 milliwatts and have a functional rotation of our turbine. Also consistent power output since we'll have a consistent wind source.
And also we mean by optimize is we want to create the least amount of friction possible, so we're not using any energy or wasting any energy.
So the benefits of the proposed design, which happens to be a vertical axis wind turbine, is that it is an open system, and with a vertical axis wind turbine we can really use maximum amount of wind energy coming from the wind source, and it is also omnidirectional, which means a wind input from any direction will help in rotating the blades of the turbine.
Some complications we found when we're designing our vertical wind turbine is kind of how we're going to support the turbine. The turbine needs to not be able to fall over in turbulent wind or the wind setting of the fan. Some friction for moving parts is going to be a complication. Where we're going to put the motor on the turbine and the gear for the generator is another complication, and there's been some current concerns about the power input compatibility.
So this is a crude design of how a power plant, the main feature of a power plant is the wind turbine, it will look like. It is basically a hollow PVC pipe with wind blades attached to it. The turbine blades are all of same dimensions and they are attached to the PVC pipe in the same fashion like a spiral staircase. And we have an aluminum rod in the center which is attached to the base, and below near the base we have ball bearings which will support the PVC pipe which is free to rotate. And with the PVC pipe we can either use a gear system or a pulley system based upon how it would turn up at the end to transfer the torque from the turbines to the motor.
I know you can't see it in the presentation shown below, but the turbine faces will be optimized so that only one side is receiving more air than the others to achieve rotation, and that both faces will not be receiving the same amount of air.
This is an estimated call sheet, and these will probably change as we go along. Some things we won't need, some things we will. That's pretty much it. This is our budget sheet, and our total cost is $20.60. 80 cents. And also the justification for this is just because the horizontal designs are kind of obsolete and they're inefficient. So the whole justification for us wanting to do wind is by 2030, we will, the 20% of the U.S.'s electricity will be from wind energy. Some of these can generate just as much energy and be smaller. So this is our justification for wanting to do a vertical axis wind turbine.
Some more justification is that we found a study about 6 years ago that was comparing vertical versus horizontal turbines. They found that vertical turbines are much more efficient at handling large amounts of winds, and so that they see more, they're more durable, and so them being omnidirectional make them a much more pragmatic use of a turbine. So that is why we decided to go with it.
A key advantage about our power plant is that we are just using 1 feet by 1 feet board, and we can still harness the 6 inches extra criteria, and we have sufficient budget of about $30 left after completing the wind power plant, so that if there is a need, we can still utilize solar energy or wind or hydroelectricity if it's optimal.
Here's our decision matrix on why we decided to use wind instead of water or solar. We feel like the kind of has a high amount of potential. It's going to be easier to work with experience-wise. Parts required, it's not going to really require as many parts as solar or water, so we have more room for air, and we feel like it's going to be pretty easy to stabilize compared to a high output water source. Here's our references, and thank you for watching.
Thank you.